Assalamualaikum warahmatullahi wabarakatuh. Assalamualaikum Cik. Okay, nama saya Wana Atirah binti Wan Ayu. Grup 9, Section 113 BEEI. Okay, saya teruskan dengan lab 4, Pulse Modulation. Okay. Objektif untuk pulse modulation ini untuk kita dapat memahami basic concept of pulse modulation dengan dapat describe and analysis the pulse modulation menggunakan MATLAB. Okay, saya teruskan dengan MATLAB. Ini adalah coding. Okay, untuk first kita buat untuk sampling rate for plotting. T-max dia sama dengan 1, Fs 500, T kosong nisbah 1 sama dengan Fs nisbah T-max. Okay, seterusnya ialah amplitude, frequency and phase shift for modulating signal. A1 sama dengan 2, amplitude 1, 2, frequency 1, 5, P1 sama dengan 0. Parameter of pulse signal adalah TF1 50, TS1 adalah 0.1, TF2 500, TS2 adalah 1. P2 Fs1 sama dengan TF1 per P bahagi dengan Tmax, Fs2 TF2 per P per Tmax. Seterusnya ialah part proses. X sama dengan A1 times sin times 2 pi F1t plus P1. Okay, U1 sama dengan gen sin square P TF1 TSL U1 equal to U1 prime. U2 is gen sin square P TF2 TS2 U2 equal to U2 prime. Pem mod 1 equal to X times U1. Pem mod 2 equal to X times U2. Okay, the output data is figure 1. Name the output data is figure 1. First graph is subplot 511 plot Tx, X label time, Y label amplitude. Title is message signal. Grid on subplot 512 plot Tu1, X label time, Y label amplitude. Title pulse signal 1. Subplot 513 plot T pump mode 1, X label time, Y label amplitude. Title pump signal 1, PAM signal 1. Next is 514 plot T U2, X label time second, Y label amplitude. Title is pulse signal 2. Subplot 515 plot T pump mode 2, X label time second, Y label amplitude. Title pump signal 2. Grid on. Okay, this is the coding of the MATLAB. So okay, this is the name graph that we have. First graph is message signal. The amplitude is 2 and the time second to complete one cycle is 0.2 second. In pulse signal 1, the amplitude is 1. The time to complete 1 second is 0.05 second. Next is pump signal 1. Graph number 4 is pulse signal 2. The amplitude of pump signal 1 is 1.68866 amplitude. Time second to complete one cycle is 0.15. Okay, the pulse signal 2 is the amplitude 1. The to complete the time second, it can be shown because it's too small. The frequency is too high, 500. Okay, next is pump signal 2. The amplitude is 2, and the to complete one cycle, period cycle is 0.2 second. Okay, that's all for coding. So I proceed to my partner.
So, thank you for my partner. Hi sir, I'm Yuhan from 3BEI S1/1. I'm here going to explain for my part, which is question and discussion. Here you can see this is a calculation for the frequency of pulse, how we get the pulse signal 1 and pulse signal 2. And for the first, you can see that the TF1 total F1 equal to 50 and the total F2 is 500. And what we want to get the signal 1 is we have to put on the total F1, which means TF1 per P, and divide by T max, and then equal to, which means is 50 over 2 and divide by 1. So which means 50 over 2 is 25. So this is 25 hertz. And for the power signal 2, we also apply the same calculation, which means is TF2 over P divided by T max. So which means is equal to 500 divided by 2, then equal to 250 hertz. And for the second, this is the calculation for Nyquist frequency for the message signal. So Fs is equal to 2Fm, and Fm is equal to Fs over 2. So we have to change the calculation to get this. And so we have to put on 500 divided by 2, so which means this is the total 250 hertz. And for the third one, what happens if minimum Nyquist frequency Fs is less than 2 times of maximum analog input frequency Fa? So if minimum Nyquist frequency is less than 2 times of maximum analog input frequency Fa, this will be known as aliasing effect. When the criteria was occur, the high frequency content by a low frequency component will represented wrongly. So here is my part. So the next I give to my partner. Thank you.
Okay, in discussion part number 4, generate the PAM signal using the Nyquist frequency and write down the coding that only change the value for TS, Nyquist frequency, and the TF. Show your calculation. Okay, this is the change that we have. TF1 from 50 change to 25. TF2 from 500 change to 250. While sampling rate from 0.1 change to 0.05. TS2 0.1 change to 0.5. Okay, let me show the MATLAB. In this MATLAB, it's same with the coding is same, but it only change at parameter of pass signal, time frame, and sampling rate. Use formula same as number 2. Calculate the Nyquist frequency for the message signal. It used this formula to generate and find the time frame and sampling rate. Okay, this is the output. The output is same, only the frequency that change. That's all.
Thank you again for my partner, and I'm going to finish our part for the last, which is discussion and conclusion. For the part here, we can see which PAM signal carries a lot more information from the message signal. So based on the result we observed, we found that the PAM signal which carry a lot of information from the message signal is PAM2. The result is referred to the frequency of the sampling rate, which TS1 and TS2 equal to 1, and it is higher when compared to the amount sampling rate TS1 equal to 0.05 and the TS2 is equal to 0.5. And for our last conclusion, you can see for the conclusion in this lab experiment, we were able to understand the basic concept pulse modulation. We had learned that continuous signals are sampled at regular intervals in pulse modulation. Hence, we also could describe and analyze the pulse modulation by using the MATLAB software. That's it for my part. Thank you.